So let's take a look at a couple different problems. X squared minus 16 equals 0 and x squared plus 16 equals 0. And I'm going to take you on a little journey back in time to discuss these different problems. Now, if you're solving this one way to solve it that I would encourage would be to move the 16 to the other side and then take the square root on both sides. Except there's one thing I'm missing here. Does anyone know what I'm missing on the right hand side that I definitely need? Yeah, the plus or minus. Well done. So x squared equals plus or minus 4. Nice. And so all is well with the world over there, the lion, lamb, and best friends, etc. Well, let's take a look at over here. We can do the same thing here. X squared equals negative 16. Well, what problem am I going to run into? Something we kind of mentioned in the last section. Yeah. Square root of negative creates problems for us. And it created problems for early mathematicians. They had to struggle with this for a couple hundred years until a mathematician by the name of Leonhard Euler came along and helped set things straight. But there was early experimentation in dealing with this. And one way to deal with this is to split off this thing right here, the square root of negative 1. And it really bothered early mathematicians to deal with this. But eventually we settled on this description of this. We're going to replace square root of negative 1 with I. And they settled on I because I is the first letter in imaginary. Mathematicians for a couple hundred years didn't think that this was real. They said, oh, it's ridiculous, it's imaginary. And they just kind of waved their hands and didn't use it. But it's actually part of the fabric of our universe. When you study areas of physics or electronics, you use these kinds of numbers. So it's a part of our real world, even though they're called imaginary numbers. Now with that definition, this becomes plus or minus 4 times I. And the big property about I that you should know that makes it so useful is what happens when you square it. What do you think is going to happen when I square I? What will I get? Negative 1. Yay. So the two things you should get here are that I is the square root of negative 1 and I squared is negative 1. So those are the two things that are critical at the start. Now, with that I, we can work with complex numbers. So complex numbers, and I know that to you that looks like hashtag, but I'm a little more old school, as you can tell. That means numbers, all right? It was numbers way before it became hashtag. Complex numbers look like this. They're A plus B times I. So there's what's called a real part and an imaginary part. So those two parts, and those two parts together make one complex number. So for examples, you could have 8 plus 3i, or 5 minus square root of 2 times I. You could have a number that's completely imaginary, 0 plus 9i, or you could have a number like 7. And you might say, well, that's not a complex number. But you could consider it a complex number if you think of it as 7 plus 0i. All of these have a real and imaginary part. And what we're going to learn to do today is add, subtract, multiply, and divide complex numbers. Now the reason we're studying complex numbers is because they're part of the solution to a lot of equations that we're going to deal with. But let's start on the friendly side first. And that is, we're going to add and subtract complex numbers. So, example A. Let's have 6 minus 7i plus 4 plus 3i. Now the thing about this is that when you add and subtract complex numbers, you really want to combine like terms. So for instance, I've got a 6 and a 4. Well, I can combine a 6 and a 4. That's just going to give me 10. What else do I got? Well, I've got a minus 7i and a plus 3i. What's minus 7 plus 3? Awesome, thank you. Minus 4i. There, done. You've combined two complex numbers. Now, kind of in a reminder to some of the work that we did with subtracting rational expressions in the last section, let's take a look at subtracting a couple complex numbers. Negative 4 plus 4i minus 2 minus 5i. And the thing that we had to be careful there is that this negative has to distribute itself to both of those terms. So it's not enough just to subtract the 2, but it's going to change the sign on the 5 as well. So I'll rewrite this as negative 4 plus 4i minus 2, and then what? Yeah, awesome, thank you, plus 5i. So kind of like the last one, you've got like terms, and let's combine them. Olivia, what do I get when I combine the like terms, please? Nice. Negative 6 plus 9i. Beautiful. All right. So hopefully, if you see something like this on an exam, you're like, oh, cool. Professor must have had a great weekend. He's all happy. He's giving us a couple easy points. That's what these problems are intended for. You know, just a couple easy points. You will find those on exams. The biggest problem I run into with those kinds of problems is that people want to do what we're going to do in this next example or next series of examples, and that is multiply. So 6 minus 3i times, or 6 minus I times 4 plus 3i. Notice the difference here. These are next to each other. Up here I had a subtraction, and then here I had an addition separating my two complex numbers. But if they're next to each other, then, well, then our work's going to look a lot different. What do you have to do to multiply two binomials? Is there a word that comes to mind that you think of? FOIL. Yeah, FOIL was the one I was looking for. Yeah, distribute is another way to say that. Let's remind ourselves of something first. What does I squared give me? Yeah, I squared equals negative 1. You're going to need that when you're multiplying or dividing complex numbers. So 24, then the outside terms, plus 18i. How about the inside terms? Somebody help me out there. Negative 4i, good. And, ooh, drum roll, please. Yasser, how about the last term? What do we get when I multiply minus I and plus 3i? Nice, negative 3i squared. The important thing that I was looking for there from him was the I squared part. So a lot of times people forget that, oh yeah, I times I is going to give me that I squared. These are like terms. Thank you, Yasser. Let's combine the like terms. 24 plus 14i. And I'm going to do this kind of slowly, but in your test and after this example, I'm going to expect that most people are just going to simplify this a lot faster. I squared is negative 1. Negative 1 times 3 gives you what? Positive 3, right? And now you've got more like terms that you can combine. I would like these combined. 24 and 3 gives me 27 plus 14i. Yay! So nice. Looking good there. Let's try another one. Actually, you got a couple more here. One of them that's kind of interesting is going to be this next one. 5 minus 4i times 5 plus 4i. These are what are called complex conjugates. It's when you're multiplying a plus bi is the conjugate of a minus bi. So to get from one term to the next, if you're looking at finding the conjugate, you're just going to change the sign in between these two things. Let's multiply this out. Something interesting is going to happen when you do that. So if you happen to be watching this later, then pause the video and resume it after you got your answer. Let me see how you guys are doing on yours. All right, so help me out here. Let's look through this first term, last term. For first term, outside terms, inside terms, last term. First terms, 25. Keep going. 20i. Minus 20i and plus 16. Actually, let's just minus 16i squared. Right? Eventually it is going to be a plus 16. But what's one of the nice things that happens right off the bat? Yeah, the minus 20i and the plus 20i, those cancel. So that's kind of cool. And what happens is that eventually you're starting out with two complex numbers, but when you have this I squared term, that's going to be a negative 1. The shortcut that I would expect to see people take here is that you're going to drop the I squared and change the sign on this. So it's going to become a plus 16 equals 41. How many of you got that one? All right, looking good, looking good. Let's try another one like that, just for some practice. And that's going to be 3 minus 4i squared. Now, there's a reason that I put this on exams. 3 minus 4i squared. It's because I want to try and help you get over the urge just to go, oh, 3 squared and minus 4i squared. You can't do that. You can't distribute this squared term. What do you think we have to do instead? Yeah, you're going to multiply it out. You're going to write 3 minus 4i times 3 minus 4i. And then we're going to run through those things again. So Noah, help me out if you would. First term outside, inside last. Go for it. Help me multiply this out. So 3 times 3 minus outside terms 3 times 4i,
12.
12i, inside terms. Minus 12i again. And thank you. Roland, how about the last one? Or Nolan, sorry. How about the last term?
So is it 4 multiplied by 3?
Last two terms would be these two. So this one and this one. So minus 4 times minus 4.
So 16i squared.
Nice, 16i squared. Cool. Now, do these cancel each other out? No. They're the same sign. So let's combine those. It's going to be 9 minus 24i. Stasha, what happens to the 16i squared term? Perfect. So let's just put a negative 16 there. Am I all done? Looking good? 100%? Probably a little something that I'd like you to do. And I kind of struggle with, if people leave it like this, I'm like, is it really worth a minus 1 point? There is one last thing that you can do to get full credit on this. What is it? Yeah, there you go. Let's just combine like terms, right? 9 and negative 16 give you negative 7 minus 24i. All right. Looking good there. Now, before we started this section, I did a little reach out to you guys, see if you guys had a graphing calculator. Now, the deal is this. I'm going to show you how to do a little trick on your graphing calculator, but I still want to see this work here. But you can check your answer. And what you'll find from me is that I'm okay with you guys checking your answer a lot. You can do that in a math class better than anything. So, from the home screen, let's type in 3 minus 4i. And let's see about squaring it. Left parenthesis, 3 minus 4. And if you're looking, it's like, well, where's the I key? It's right there above the decimal key. What do you think I got to do to get that I out of my calculator? Yeah, you have to hit the second key. Second, and then I, right parenthesis, and then the really power move that you can do here is just hit the square button over here to the left. So 3 minus 4i squared, and bam. Ooh, yeah. Yeah, how about that? Give it up. Give us a little love on that one. 3 minus 4i squared, negative 7 minus 24i. So you can check your answers with these things before you hand it in. There's nothing wrong with that. I encourage you to do that. I want you to get the right answers. So there you go. I'm not going to give you credit if you just give me the answer, all right? I need to see the work. But you can check it. Nothing wrong there. All right. Let's see here. Let's do a couple more. Are we okay with this? Yes.
Is there a reason why I'm getting an error in my calculator?
Probably forget the thing.
No.
Let's see. Bring it up. Okay. So the subtle difference here, if you take a look in between these things, you use the opposite key to plug in the minus. So
I did. You're right.
if I go back here and I put in a subtraction in there, this should work. No worries, no worries. Okay, let's take a look at another one. Now I mentioned what a complex conjugate was, but let me actually give you the notation for that. So we'll call this example D. So it's going to be multiply 5 plus 9i times 5 plus 9i. And let's put that conjugate in there. And let's see. Let me do it nice and bold. And so that little line there means conjugate. Take the conjugate. So what's the conjugate of 5 plus 9i. Don't multiply yet. Don't multiply yet. We need to take the conjugate first.
5 minus 9.
Yeah, well done. Thanks, Tasha. 5 minus 9i. Now you can multiply those together. Now when you multiply conjugates together, we've seen a couple times, or we'll see again here, that the complex part disappears, and that's kind of cool. That's a minus in here. 9i times negative I9. 9i gives you negative 81. Somebody fill in the rest. Negative 81. I squared. Excellent. Now those middle terms cancel each other out. You should get a lot of simplification here. So the middle terms disappear. They add to 0. And when you started out with two complex numbers, you ended up with a real number. Now, you don't have to write 106 plus 0i. It's just good enough to write 106. Nice. Nice. How are we looking on those so far? Doing okay? Let's finish this up. We're going to finish it up with a couple division problems and the maybe powers of I. So for the division problems, we're going to use this idea here that when you multiply a number by its conjugate, you get a nice real number. Mathematicians just have an aversion to having square roots and imaginary numbers in denominators, so we're going to avoid that with our conjugate. Let's suppose we had 5 over 2 plus I. Now the unfortunate part is that really that puts a radical in the denominator and a complex number in the denominator. So what we're going to do is try and get rid of that complex number from the denominator. I'm kind of really anxious to get you guys on a quick break. Let's see what we can do here. So I'll help you out a little bit. The trick here is to use the conjugate. I'm going to multiply by 1, but I want to use it in the form of the conjugate. So what would the conjugate of 2 plus I be? Yeah, 2 minus I. So we're going to multiply by 2 minus I over 2 minus I. Now in the numerator, I can just distribute. That's going to be 10 minus 5i. But in the denominator, I've got a little bit more work to do. So let's see. Who can help me out? Elijah?
So
4. 2 times negative I. And then inside terms. And then the last term. Yep, negative I squared. Nice. So let's see, that's going to be 10 minus 5i in the numerator. Lots of simplification in the denominator. Thanks, Elijah. Olivia, do you see anything that's going to simplify in the denominator? Good. So negative 2i and plus 2i cancel each other out. How about this negative I squared term? Jeff, what happens to that? Close, not 1, but actually I squared is just negative 1.
He's talking about the,
Oh, I'm thinking ahead. Sorry.
Oh, so you're thinking the double negative becomes a positive? Yeah. Yeah, yes, it does. So 10 minus 5i over 5. And this is just so nice and neat and handy that let's just do this. That 5 can cancel itself from both of these terms. That'll leave me with 2 minus I. Yay. Now, a lot of times, the WebAssign is going to ask for an answer in this form of A plus BI. So, kind of be on the lookout for that. And in the next problem, we're going to have to clean things up a little bit more because of that. But are we okay here? All right, let's take a look at one last example. That's going to look like this. Let's see. 3 minus 8i over 1 minus 3i. Okay. Take a moment for yourself and decide what we're going to multiply by this time. Justin, what do you think? What are we going to multiply by this time? Yeah. So we're going to multiply by the conjugate of the denominator always. So in this case, it's going to be 1 plus 3i and 1 plus 3i. Now there is some patterns in the denominator you can kind of get familiar with. I am going to kind of FOIL it out. 1 plus 3i minus 3i minus 9i squared. How about the numerator? Riley, can you help me multiply out the numerator?
3 plus 9
Good.
minus 8i minus 24i squared.
Nice. And I always appreciate when people give me the I squared. Thank you so much. Again, the typical simplification in the denominator. Those two terms cancel each other out. What happens to the minus 9i squared term? Brandon? What's going to happen there?
It's going to be negative 9 times negative 1.
Which would give me what?
9.
Yeah. So I end up with 1 plus 9 in the denominator. Thank you. And then 3, let's see. Noah, I have some like terms here that I can combine. What do I combine? What do I get when I combine these two, please?
I.
Yeah, plus I. Now, if you want, you could put 1i. I don't really care to see the 1i. If you want to put 1i there, I'm not going to complain. Thanks, Noah. How about this last term? What happens there?
24.
Plus 24. So altogether, we get 27 plus I over 10. Now, I'm okay here, but WebAssign is going to want this broken up a little bit more. 27 over 10 plus 1 over 10 times I. That's for WebAssign. It's not for me, but there's reasonable reasons for asking for something like this. That's because your real part and your imaginary part mean different things in different contexts in physics, so you kind of like to keep them straight. That's why we always like to keep them in this order as well of A plus BI, is because, the order does make a difference. They refer to different things. All right, I will show you a couple last quick examples. I've become less convinced that they're worthy of test questions, but they are in the homework. So last but not least, example F. I to the 34th. The thing that I want you to remember the most is this. The thing that's going to get you through this section in this course is I squared. What does I squared equal? -1. And that's the only thing you're going to have to remember to do these types of problems is I squared is -1. Let me demonstrate. I'm going to rewrite this as something involving my I squared term. But if I want this and this to be equal, what exponent am I going to put on the outside of this? 17. That's all I needed. Thank you. 17. Good job. So I squared becomes negative 1. And I hope that you don't have to take out your calculator to do negative 1 to the 17th power. You've got an odd number of terms here, so that's just going to be negative 1. If you had something like I to the 72 power, we do the same. You're going to start out by writing I squared to the 36th, which is negative 1 to the 36th power. This time we have an even number of negatives, so what's that going to mean for our answer? Positive 1. Now you might object and say, well, wait a minute. You're giving us the easy ones. Yeah, I am. But you can do the harder ones with this same idea. There's just one problem. If you have an odd term to begin with, let me ask you to recall something. Recall a to the n times a to the m. What happens when you multiply things with the same base? What do you do with their exponents? Add them. So I can kind of work this in the opposite direction. I can rewrite this as I to the 400th times I to the 1st. Now what's the benefit of that? Well, the benefit of that is that I can rewrite this and just ignore this. I'm going to put my I squared here in the middle as before. What power is going to be outside here? What times 2 is going to give me 400? 200. And that's going to become negative 1 to the 200th power times I, which is going to be what? What's I at negative 1 to the 200th power? 1 times I, or just I. That one seemed to go over a little bit rougher than some of the other ones, so let me just do this one last example, and that'll be it. I to the 71st power, I'll rewrite that as I to the 70th times I to the 1st. Your trick, as always, is to rewrite this as I squared. But I squared to what power? What times 2 gives me 70? Yep, 35. And as before, you've got negative 1 to an odd power. What's negative 1 to an odd power? Negative 1. Altogether, when you're working with powers of I, there's 4 possible answers. Could be negative I, could be positive I, could be 1, or it could be negative 1. There is actually a different way to do this, but it requires you doing some memorization, and I don't like it as much for that reason. But if you do it a different way, that's fine. Just show me your work. Okay. Thoughts on that last one? All right. Let's take a break.